Jai Hind. I am Lady Cadet Pallavi from Armed Forces Preparatory Degree College, Bongir. Today I am here to speak on the topic Maglev trains, theory or technology. Let me see the objectives of Maglev trains. In this class, we are going to learn Maglev trains history, Maglev trains theory and technology, existing Maglev trains, comparison between Maglev trains and conventional trains, advantages and disadvantages of Maglev trains, and scope of research. Now let me clearly explain the objectives one by one. The evolution of mass transportation has fundamentally shifted human civilization. If we see the olden transportation, the first form of transport is walking. Our ancestors used to walk in order to meet their basic needs. Fortunately, human beings learned to use animals like camels, horses, donkeys, etc. for the transportation purposes. Later, the wheel came into existence, which led to the production of vehicles like cars, buses, bikes, etc. Today, we are using public means of transportation with the help of wheels. As with the transportation is often divided into different modes like airways, railways, waterways and highways. If we see, the conventional mode of transportation, along with increase of population and increase in expansion of zones, there would be a public demand for the public means of transportation have increased. In order to serve the public, there is innovative means of transportation must serve. We should have qualities like rapidity, reliability and safety. Maglev is one of the best. We have always thought of aeroplanes as the fastest mode of transportation, as it travels thousands of miles in an hour without any delay. People thought that there is no other alternative to planes which can clearly compete in both speed and safety. But I came up with a solution, Maglev trains. Let me clearly explain. If we see the conventional mode of transportation like bus, car, aeroplane, train, conventional train, etc., there are different drawbacks from different means of transportations. If, for example, I would like to give a lively example. If we take a bus, if I want to travel from one place to another place within 5 minutes, it may be urgent. I can't reach within 5 minutes by bus because there would be different problems like traffic. For example, if we take Hyderabad city, there would be very traffic. If we want to reach a place within 5 minutes, it's take about 10 to 15 minutes. In order to overcome all the drawbacks of this public means of transportation, I came up with a solution, that is Maglev trains. Maglev trains are fast, comfortable, pollution-free, energy efficient and weatherproof. Today's world is developing in technology as we are using Maglev trains for the purpose of high-speed trains. Next, coming to where the Maglev trains have started. Magnetism has fascinated humans for many centuries. We have played with magnets. We know that magnets attracts and repels. We thought that there are many daily life applications of magnets, like magnets are used to treat cancer. They were used for the doors of refrigerators and freezers. But I am applying the Maglev trains theory for the transportation system. Now let us see how the transportation system how magnets will help transportation system. Let me explain the history of Maglev trains. In 1904, the Maglev train theory was created by Robert Goddard, who was an American scientist. It became interesting for many countries around the world. But later, Japan and Germany started using Maglev trains. They started researching and designing the functional Maglev train. But in the year 1970, Eric Robert Laithwaite, who was a British electrical engineer, invented the functional Maglev train. His first invention was linear induction motor. He worked for several years, and with the linear induction motor, he introduced a functional Maglev train to develop high-speed trains. Eric Robert Laithwaite is also considered as the father of Maglev. Shanghai train. Shanghai train is the first fastest Maglev train. It was started in the year 2004. The Shanghai train runs between financial district of Shanghai to the Shanghai's Pudong airport. Next, coming to the interesting fact, I am more interesting about the speed of the Maglev train. The speed of the fastest train, that is the first fastest train, Shanghai train, It is nearly 603 kilometers per hour. Let me explain Maglev trains theory. Have you ever played with magnets? Since childhood, we come to know that unlike poles attract and like poles repel. If this is a magnet, it has south pole and a north pole. When two like poles are kept together, then there will be repulsion. If this is a magnet having north pole and this is a magnet having south pole, when they are kept together, the two unlike poles attract. Since childhood we are playing with magnets, but now we came to know how magnets play a vital role in technology. One interesting fact about magnet, that is, no individual pole exists. We could always see a north pole and a south pole to a magnet. Here the image clearly shows north pole and the south pole. Where the north pole and the south pole are attracting, the south or the north and the north poles are repelling. Before going to explain deeply about the Maglev train function, let me say the major principle behind the Maglev train operation is magnetic repulsion. Maglev train's theory. This Maglev train is a train which floats above the train about 10 centimeters. That is called magnetic levitation. Let me clearly explain. The levitation is the object which floats over the track by means of magnetic power is called magnetic levitation. In the same way, we could also have levitations in water and levitations in air. The levitation in water, which is known as buoyant levitation. We could see the ship traveling on the surface of a water is due to the buoyant force which is acting. For example, if I throw a pebble into the pond, the pebble will go deeper into the water. This is due to there is negative buoyant force. The buoyant force is both positive and negative. In order, the ship is traveling on the surface of water is due to positive buoyant force which is acting. In the same way, the train floats on the surface of the track. In the same way, the ship floats above the surface of the water. This is the reason why ship floats in the water instead of immersing in it. Next, coming to aerodynamic levitation. This aerodynamic levitation, the wings of the aeroplanes were constructed by seeing the bird's wings. The wings of the birds and the aeroplane wings are foil shaped. Due to that, there are force exerted in order to push off the train and move forward. As the bird is moving in a forward and flying, in the same manner the aeroplanes were constructed and they are also moving with high speeds. Let me explain the term maglev. The train is named as a maglev because the term itself says it is a combination of two words. Maglev is nothing but magnetic plus levitation. Magnetism has fascinated humans for many centuries. The term levitation is a Greek word which means rising or floating. The term maglev itself says we are using magnets and the system of levitation we are using, so that this train is named as maglev train. Initial thought towards maglev trains. Maglev trains uses two sets of magnets. One set of magnet is used to push off the train and another set of magnets are used to elevate the train. Here the image clearly shows there are two sets of magnets. This is a model of maglev train function where the pencil indicates the maglev train which is floating about 10 centimeters of the track, and there are two sets of magnets. One is to push off the train and another set of magnets are used to elevate the train ahead. There are three basic principles of maglev trains. It functions in three ways: levitation, propulsion and lateral guidance. Let me clearly explain the maglev train functions one by one. Levitation. The object which may float due to magnetic power is known as magnetic levitation. There are two techniques involved in the magnetic levitation are electrodynamic suspension system and electromagnetic suspension system. In electrodynamic suspension system, we mostly use superconducting materials. Firstly, let me explain what a superconductor is. A material which obeys three properties like zero resistance, perfect diamagnetic, which exhibit Misner effect, is considered to be a superconductor. This superconductor is used in the maglev trains in order to power the train. Let me clearly explain electrodynamic suspension system. Here we could see the magnetic levitation with superconductor where the rare earth magnet is floating above the superconductor disk. This is how the train floats in the same manner. Let me clearly explain electrodynamic suspension system. Here in the image we could clearly see the levitating coils, a superconductor, the guideway, the guide walls. Let me explain. When a superconductor material is passed through the levitating coils, then current is induced in them, and this induced current creates a magnetic field. The force in track is created by magnetic field in coils, therefore the train pushes in upward direction. The train levitates 10 centimeters above the track. This is the principle behind the maglev train levitation. Electrodynamic suspension plays a vital role in levitating the train. Till now I have explained in theory. Let me explain by a diagram and taking a law. According to Faraday's law states that when there is change in magnetic field, then current is induced. Here we could see the second image. When the magnet is coming towards the levitating coils, then current is induced in the coils and it creates a magnetic field. In order to levitate the train, the force must be needed. So, this is all about the electrodynamic suspension system. Let me clearly explain electromagnetic suspension system. If everyone knows that the train tracks are parallel to each other, they never intersect with each other. If they intersect, there may be accidents occur. So that we always see the parallel lines which could be seen in the train track. Let us consider two train tracks as two parallel conductors where the current is carrying in first conductor and the second conductor. As current is conducted, then automatically the magnetic field will be induced. Here in the two conductors, the first conductor is having current as well as a magnetic field induced in them. The first magnetic field of the first conductor will affect the second conductor, whereas in second conductor also we could see the passage of current and induced magnetic field. The field of the second current affects the first conductor. So there will be repulsion force occurs which helps the maglev train to levitate. Here we could image clearly shows how a magnetic field is produced, the direction of magnetic field and the direction of current. Let me explain it clearly by having Ampere's law. Ampere's law states that when there is change in current, magnetic field is induced. Let me explain clearly with the help of right thumb rule. According to right hand thumb rule, if I carry a superconducting material in my right hand and I stretch my fingers, the thumb finger indicates the direction of current and the four curled fingers indicates the magnetic field. This occurs in the track where the current is produced and the magnetic field induced in them so that the train can levitate and move forward direction. For example, I would like to say, if I place an object on a table and if I want to lift the table, I must apply a force on the object. Unless I apply a force on the object, I cannot move the object or I cannot lift the object. In the same manner, there must be force acting on the maglev train. As I told that the maglev train levitates about 10 centimeters. It is lifting up. So there should be some force which is lifting up. That is called magnet force. This magnet force could be explained by Fleming's left hand rule. Here the thumb finger indicates the magnetic force, the index finger indicates the magnetic field, the middle finger indicates the current. As there is current is induced in the coils, then it creates magnetic field. Then also we required magnetic force in order to levitate the train. Levitation due to magnetic repulsion. As there is repulsion, we could see the elevation of the train ahead. The next function of maglev train is propulsion. Electromagnetic coils are placed on the guide walls of the guideway, then alternating current passes through electromagnets. It creates, as a current is passing, then automatically the magnetic field will be induced. It creates a magnetic field that attracts and repels the superconducting magnets. Here we could see the image. There are electromagnetic coils. The current is passing in it. We have placed the superconducting magnets on the track. We could see the guideway, electromagnetic coils. When a superconducting magnet is placed on that and current is induced in it, then it creates a magnetic field which helps the train to propel forward. Propulsion is nothing but moving the train in a forward direction is nothing but propulsion. As a result, the train moves in forward direction. This is all about propulsion. Next, let us learn the third main function, that is lateral guidance. According to lateral guidance, we could say there will be no accidents occur because there will be two forces, induced forces acting in lateral guidance, attraction and repulsion. The repulsive force from the levitation coils on the side closer to the train, but whereas the attractive force from the coils on the farther side, whereas it balances and never let the train to move in another direction. So that this lateral guidance keeps the train in the center and moves safely. In this way, there are three functions which I have explained till now. Levitation, propulsion, lateral guidance are the three important functions which led the maglev train to move forward, to levitate, and all these could explain how a maglev train run. Now let me clearly explain existing maglev trains. There are maglev trains in China, South Korea, Japan, Germany, etc. These maglev trains also became for solutions for many countries. In the 21st century, many countries like South Korea, China, Japan are using powerful electromagnets to develop high-speed trains which are maglev trains. Firstly, Japan people used technology of maglev trains. Then Germany, Japan, China, they also used. But there are two types of systems they have used. Whereas the Japanese people used electrodynamic suspension system, and whereas the Germany people used electromagnetic suspension system. These are the two techniques which were used in the levitation of maglev trains. Till now, I have explained how maglev trains work and the functioning of maglev trains. Now let me explain the tragedy which was happened on August 11, 2006. A maglev train accident occurred on August 11, 2006. People still researching to find what is the problem behind it, but they made sure that no further accidents happened. No further accidents have reported since today. Maglev trains. There are existing maglev trains in Daejeon Expo Maglev, which is in South Korea. It is running since 1993. The Shanghai maglev train, which is the first fastest train, which is in China, it is running since 2002. The Linimo, which is in Japan, it is running since 2005. Incheon Airport Maglev, which is in South Korea, it is running since 2006. Changsha Maglev Express, which is also in China, it is started running since 2016 and the top speed is nearly 100 km per hour. Next, Beijing S1 line, which is also in China, it running since 2017. Comparison between conventional trains and maglev trains. There are many features regarding conventional trains and maglev trains. If I take the speed of the trains, the speed of the conventional trains is limited. We cannot reach within minutes or within hour a long distance, but whereas when compared to the maglev trains, we could travel a long distance in minimum amount of time. These maglev trains are competing equally with aeroplanes in both speed and safety. Next, coming to the maintenance. The maglev trains there is low maintenance in maglev trains and high maintenance in conventional trains. All weather operations. Conventional trains were affected by weather conditions. They were be affected by severe cold, rain, etc. as it also emits pollutions. Next, coming to the maglev trains, they were unaffected by severe cold, snow, rain or high winds. The fastest trains move faster irrespective of weather. So this is a good, the maglev trains are less susceptible to weather. Next, coming to efficiency of conventional trains and maglev trains. As there is no rolling friction in maglev trains because there is no physical contact between the train and the track. As previously I have explained, the train levitates about 10 centimeters, so it says that there is no physical contact between train and the track. Whereas in the conventional trains, it is affected by rolling resistance because there is physical contact between train and the track. There are many comparisons between conventional trains and maglev trains. By comparing, we come to know that the maglev trains are the best trains, which could also develop high speed, high safety, etc. Advantages of maglev trains. Maglev trains reduces maintenance cost by a significant extent. There is no physical contact between train and the track, so there is no rolling resistance. There is no friction which could ensure the train moves in a top speed direction. So absence of wheels deal with deafening noise. It also reduces noise pollution. Whereas in conventional trains we could see the wheels which make noise and lead to the noise pollution. Maglev trains are eco-friendly. As they are eco-friendly because there will not be any noise pollution. As conventional trains uses engines, the maglev trains uses magnets. So there will be many differences. There is a lot of change that they are using engines which may cause air pollution, which may affect the environment, but whereas maglev trains are using magnets which may not affect the environment, they are eco-friendly. Maglev trains are weatherproof. They are less susceptible to weather. They can bear severe cold, heavy winds, etc. High-speed trains are the maglev trains, and also the high-safety trains are maglev trains. They have both high speed and high safety. Less pollution and low energy consumption. Recently I have said that there is no noise pollution. They are eco-friendly. It clearly says that there is less pollution due to maglev trains. But whereas due to conventional trains, the environment is damaging day by day. So it is better to use maglev trains in our country also. Less energy consumption, it says that the maglev trains are using 30% less energy than conventional trains are using. Next, coming to disadvantages of maglev trains. The initial cost of the maglev trains is very high. We must have many lakhs of dollars in order to build these maglev trains. So India is trying, but it couldn't came up to build maglev trains. So it is also, the guideway is also very expensive, and there will be some few health concerns due to electromagnetic waves. As we are using powerful electromagnets for the high speed trains in maglev, it may causes health concerns due to strong electromagnetic waves. And due to lack of existing infrastructure, we could not construct a maglev trains. If there is a maglev train construction, nearby there should be no electrical appliances, so that we can construct a maglev train. It occupies a vast space. So it is really a critical thing to construct maglev trains. Scope of research. Till now I have explained the maglev trains. Let me explain the research which is going on hyperloop trains. The maglev trains are moving on the track with the speed, the Shanghai fastest train with the speed 603 km per hour. But now I am going to say the hyperloop trains, still research is going on these hyperloop trains, which are also called VAC trains. While the maglev train is moving on the track, there will be some air resistance. Due to that, we are developing high speed trains due to maglev trains, but there will be some air resistance. In order to decrease that air resistance, the scientists came up with a solution, hyperloop trains. The trains are placed in the vacuum tube to eliminate air drag force. In order to eliminate the air, we could develop the high speed more than maglev. If the maglev train speed is 603 km per hour, the speed of the hyperloop trains are nearly 1200 km per hour. So imagine how fast the train is moving. So scientists are still designing. By 2020, the hyperloop trains may come into existence. Let me summarize what I have explained from starting till the end. Driving without wheels, flying without wings. These are maglev trains. These are the extraordinary trains which could develop high speed trains And these trains, in the absence of friction, they can reach high speeds. The high speed technology is developed due to maglev trains, and maglev trains use magnets to levitate and propel the train forward. Maglev is the safe and efficient way to travel. India is also trying to construct maglev trains, as India is a vast country where the huge population exists. There is a great use of the maglev trains. So researchers are finding a solution to construct maglev trains in India too. There are future plans in India, like there may be maglev lines in between Mumbai to Delhi, Mumbai to Nagpur, Chennai, Bangalore, Mysore. So there will be maglev train construction in future. We could see and we could develop high speed trains where a large population exists in India. I may conclude by saying that we may see maglev trains in future too. The maglev trains are playing a vital role. This technology is absolutely a very great thing. This brought many countries to a great extent. I hope this maglev trains technology, by the construction of maglev trains technology in India, it also bring India to a great extent. Thank you. Jai Hind.